All right, we're back for some more SOHCAHTOA. Before we get started though, please do a calculator check. Check your calculator. When you hit sine 33, you should get 0.5446 with a few more decimals. If you're not getting this, your calculator is probably in radians and you need to switch it to degrees. All right. Our first focus for today is going to be working on sine, right? Which we know from SOHCAHTOA, that's the so part. And we know that the so stands for sine equals opposite over hypotenuse. So when I go to solve this problem, I'm going to identify that this is my angle, and x, the side that I need to find, is my opposite. And then the other side that we know is the hypotenuse. All right, we don't know the adjacent, we're not finding the adjacent, so we're not going to do anything with the adjacent. But if we're using opposite and hypotenuse, then we know our trig function will be sine. So this will be a sine problem. When we go to set up this problem, we're going to do sine of the angle, so sine of 57 equals what over what? That's right, it's going to be x over 15. And then we can turn this into a proportion, right, by making the sine 57 a fraction over 1. And then we can go ahead and cross multiply. X times 1 is x. And then for sine 57 times 15, sometimes you'll see that written as 15 times sine 57. Sometimes you'll see it written as sine 57 times 15. Doesn't matter which order you show it, as long as you make sure you don't multiply the 15 and the 57. We need to find what the sine of 57 is. So sine 57, and then multiply that by 15. And I get that x has to be 12.58. So the length of this side right here is about 12.58 units. Okay, similar problem. I'm going to identify that the angle I'm finding is the hypotenuse. I'm going to identify that the 10 is my opposite. And if we are using the opposite and the hypotenuse, we know it will be a sine problem. I'm going to set that up as sine of the angle, sine of 43, equals 10 over x. So this time our x is on the bottom of the fraction instead of the top. And what you'll start to figure out is that means we're going to end up dividing at some point in this problem, whereas on the last problem we just multiplied and we were done. But anyway, as long as we can cross multiply, we'll be able to figure it out. 10 times 1 is 10. And then sine 43 times x is x times sine 43. And at this point, we want to get the x by itself, but it is getting multiplied. So how do I get the x alone? We are going to divide by sine 43. Not 43, but the sine of 43 degrees. So in my calculator, I'm going to do 10 divided by, and then sine 43. Your calculator might have to hit 43 and then sine, but hopefully you figured out your calculator at this point. And I get that x is about 14.66. So the length of this hypotenuse is about 14.66 units, which makes sense because the hypotenuse should be the longest side, and I got a value that is longer than the leg that we already know. If I got a number here that was less than 10, that would make no sense at all, and I would know I made a mistake. So that's kind of a quick way to check if your answer is reasonable. Okay, what is significantly different about this problem? Well, the big difference is we are now finding an angle measure. So if we're finding an angle measure, we're not going to use sine or cosine or tangent, we're going to use the inverse of sine, cosine, or tangent. So I'm going to go to the angle that we're finding, and identify that this side is the opposite. This side is the hypotenuse. We do not know the adjacent, not using the adjacent at all. So if we just have O and H, we can go back to so, ka, toa. O and H go with sine. But because we are finding the angle, anytime you are finding an angle measure using trig, we are going to use the inverse. So sine -1. What will go in my parentheses? Well, since we're doing the inverse sine, we need opposite over hypotenuse. So this should be 17 over 25. And this is where our calculator does the rest of the work for us. We just need to do inverse sine. So you might need to hit shift or second to get to your inverse. And then I'm going to plug in parentheses 17 divided by 25, which is approximately 42.84. And since it's an angle, our units are degrees. Most of the time with angles though, we just have you round to the nearest whole degree. So this would round up to 43 degrees. All right, let's go ahead and do one more of these. We've got our angle is angle Y. That's the one we're calculating. We know that 5 is the opposite. We know that 12 is the hypotenuse. So opposite hypotenuse, we know it's sine. We're finding the angle, so what type of sine do we need to use? The inverse sine. So I'm going to do sine -1 of opposite over hypotenuse. And why don't you go ahead and plug that in your calculator and see what you get. All right, let's go ahead and check how you did. When I do inverse sine of 5 over 12, I get that that angle is 24.62 degrees. Or if we round that, that would round up to 25 degrees. All right, so sine, we use it anytime we have the opposite and hypotenuse. We're gonna go ahead and move up to cosine, not up, move on to cosine. And it's the same thing we did with tangent, it's the same thing we did with sine. The only difference is because it's cosine, it means that the two sides we're using are going to be the adjacent and the hypotenuse. So if those are our two sides, that means cosine is what we're going to use. So if I go to this angle, I know that 16 is the hypotenuse. The opposite would be over here, which means x is going to be the adjacent. So how would we set this problem up? What would our equation be? That's right. Great job. You guys are so good at this. So we're going to go ahead and do cosine of 52 equals the adjacent over the hypotenuse. We can go ahead and set up our proportion. Cross multiply. X equals cosine 52 times 16. So cosine 52 times 16, which gives me a whopping 9.85. So the length of this adjacent side is about 9.85 units, which is reasonable because it should be smaller than the hypotenuse. Well, it has to be smaller than the hypotenuse. So that number seems pretty reasonable. All right, let's go ahead and have you try this one. Go ahead and solve for x. All right, so this one was a little bit trickier. We know that adjacent is 10. We know that x is our hypotenuse. So when we go to set the problem up, we have cosine of 24 equals 10 over x. And the only reason I said it's a little trickier is we have the x on the bottom, which means we're going to end up dividing in this problem instead of just multiplying. So I can cross multiply to get 10, cross multiply to get x times cosine 24. And then our goal is to get the x by itself. So we're going to divide by cosine 24. What we do to one side, we always do to the other. And so I end up x equals And then in my calculator, 10 divided by cosine 24, which was 10.95 if we round it. So the length of the hypotenuse is 10.95 units, which is larger than 10. So that's good that our hypotenuse was longer than the leg. All right, hopefully you're starting to get more confident with this and you're realizing that, hey, once I kind of got how to do one problem, the rest is all the same, right? It's pretty much the same. We do need to be able to recognize, though, that if we're finding the angle, we're not going to use regular trig, we're going to use our inverse trig. I know that this side here is adjacent. I know that this side is the hypotenuse. That gives me cosine. But angle means it's inverse. So inverse cosine of adjacent over hypotenuse. Go ahead and plug that in. What's the measure of this angle? Well, let's see if we agree. I got inverse cosine of 12 divided by 19 is 50.83 degrees. Or if we round it, that's 51 degrees. Okay, one more inverse problem. We're finding angle B. 16 I know is the adjacent side. And I know that 18 is the hypotenuse. So what will this one look like? What are we going to plug in our calculator? That's right, we're using our inverse. So cosine -1, or inverse cosine, of adjacent over hypotenuse, 16 over 18. Plug that in the calculator, and I get 27.26, or if we round it, that is 27 degrees. All right, so we've done tangent. We started this lesson with sine. We just finished cosine. So now we're not going to tell you which one to use. And this is what we want to really get to, is where you have to look at a problem, analyze it, and go, oh yes, I should use sine, or I should use cosine, or I need to use inverse, right? And so you go through a process and figure out, based on what we have, what can we use. So this problem, I recognize that this side across is the opposite. That's what I'm finding. I know that this side here is the adjacent. So which trig function am I going to use to solve this problem? Yeah, tangent, right? We are finding the opposite. We have the adjacent, that's O and A, which goes with TOA, right? So we're going to do tan of 40, right? Tan of the angle equals opposite over adjacent. I'm not going to go through and solve the rest of this, but we're just pointing out, what is our plan? Well, our plan, because we had opposite and adjacent, was to use tangent. Okay, how about part B? Well, I know this side is opposite. I know that the longest side is the hypotenuse. I don't have anything for the adjacent, so I'm not using A. So which trig function should we use on this one? That's right. Because we have O and H, that will be a sine problem. All right, if I set it up, it would be sine of 20 equals 15 over x. And then we can plug that in our calculator and solve. And then finally, we've got, we don't have the opposite side, right? I do have the one next to it, which is our adjacent. And I do have my hypotenuse. So A and H. What should we use for this one? That's right, we should use our cosine. So cosine of 60 equals x over 6. If we're trying to find an angle, it would be the same process. We would identify which two sides we have, and if we had opposite and adjacent, we would do tangent. The only difference is if we're finding an angle, we would use inverse tangent. Or if we were finding an angle here, we would do inverse sine, etc. All right, you guys are doing great. Trig's one of those things that it looks kind of scary, but once you get the hang of it, it's like, Yeah, I'm doing some advanced level math, and I know how to do it, and I'm good at it, right? Feels good. Anyway, just want to look at least one more example, maybe we'll do two, of kind of putting it all together even a little bit further. So in this example, we're being asked to find all of the missing sides, so not just x, but also y. And then we're also asked to find the missing angle. Now, I'm going to be kind of smart right here, and I'm going to say trig is great, but I don't always have to use it if there's an easier way. If I know that this angle is 25, and I know that this angle is 90, do I really need to use trig? No. How many degrees are in a triangle? 180, right? So if I know there's 180 degrees in a triangle, I can subtract 25 and 90, right? If I add those together, that's 115. So I can subtract the 115 degrees I already have, and I know without a shadow of a doubt that this angle here is 65 degrees, right? I didn't need trig to do that because I already knew triangle sum is 180 degrees. Now, if I only have one side length and I need to find a second side length, I do need to use trig. So in this particular one, I'm going to ignore the y for a minute. And actually, I'm going to ignore this 65 as well, just so I don't get confused by it. If I use this 25-degree angle, I know that x is the opposite, and I know that 10 is the hypotenuse. So if I want to solve for x, I can use O and H, right? Which trig function uses opposite and hypotenuse? Sine, very good. So I can do sine of the angle, sine of 25, equals opposite over hypotenuse, x over 10, and then I can cross multiply, and I get x equals sine of 25 times 10, which is about 4.23. So I know that this has a length of 4.23. Okay, so I found x. I found this angle already was 65. So the only thing left to find is y. And I'm going to go ahead and label that as the adjacent. And since this was a decimal, I'm just going to go ahead and use 10 because 10 was already here, right? And I already knew that this side was the hypotenuse. So if I'm trying to find the adjacent and I have the hypotenuse, which trig function will I use? Absolutely, we'll use cosine, right? Adjacent over hypotenuse. So cosine of 25 equals the adjacent, which is y, over the hypotenuse, which was 10. And just like any other trig problem, set it up, cross multiply, and y equals cosine 25 times 10, approximately 9.06. So we use triangle sum to find that angle S was 65 degrees. I used the 25-degree angle and sine to find that x was 4.23. And then I used the 25-degree angle and cosine to find that y would equal 9.06. Side note, if you wanted to use the 65-degree angle and rename this the opposite and this one the adjacent, you're going to get the same answers. So it doesn't matter which one you do. All right, I was going to do a second example of this, but you guys have already paid a lot of attention today and answered a lot of questions. So the one thing I do want to show on this one is to find the first angle, I could use inverse, and I could use inverse cosine to get W. I'm going to make you do it. Well, I'm going to make you watch me do it. All right, so if we're finding angle W, this is our adjacent. 26 would be our hypotenuse. So A and H make cosine. But now that I'm finding the angle, I don't just use any cosine, I use inverse cosine. So So inverse of adjacent over hypotenuse. So inverse cosine 24 over 26 gives me 22.6. I'm going to round that to 23 degrees. Okay, let's get rid of that and put 23 degrees. Okay, I could very well go to this one and use opposite over hypotenuse and use inverse sine. Or if this angle is 23 and this angle is 90, can't I just add them all to 180? Right, and get that this angle has to be 67 degrees to make the full triangle 180? Yes, I can. All right, so then my last thing is finding this side here, which I might feel like, okay, I guess I need to use trig, and I can do opposite over hypotenuse and do sine of 23, or maybe I want to do opposite over adjacent and do tangent of 23, or what else could we use? You can use trig. But what else could we use in a right triangle to find the third side if we already know the other two? That's right. We've been practicing the Pythagorean theorem. So I could do, instead, I could do 24 squared plus x squared equals the hypotenuse squared. And if I use trig, I promise I'll get the same answer I'm about to get. But I could also do it with Pythagorean theorem, which you guys are very, very good at using. 26 squared, 676. Subtract 576. And x squared equals 100. And I'm pretty sure you know the square root of 100 is 10. And in my eyes, you guys are all a 10. Okay, that was a lame joke. Anyway, yeah, so trigonometry, sine, cosine, tangent. We're doing great. That's all. Goodbye.